Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn about another important geometry quantity called volume. Specifically, we're going to learn what volume is, and what kind of units we use to measure volume, and how we can calculate the volumes of a few simple geometric shapes. The first thing you need to know is that volume is a quantity that all three-dimensional objects have. But to understand what it means, it will help if we back up just a little and start out with a one-dimensional object, like this line segment. To measure a one-dimensional object, we need a one-dimensional quantity, which we usually call length. The length of this line happens to be exactly 1 centimeter, which is a common unit for measuring length. And in the Math Antics video about area, we saw that if we move or extend this one-dimensional line in a direction perpendicular to it by a distance of 1 centimeter, it forms a two-dimensional object called a square. Two-dimensional objects are measured by the two-dimensional quantity that we call area. Because the original line was 1 centimeter long, and we extended it a distance of 1 centimeter, the amount of area that this square occupies is 1 square centimeter, which is a common unit for measuring area. Okay, now imagine that we take that two-dimensional square and move or extend it in a direction perpendicular to its surface by a distance of 1 centimeter. It forms a three-dimensional object that's called a cube. And to measure a three-dimensional object like this, we use a three-dimensional quantity called volume. Volume tells us how much three-dimensional space, or 3D space, an object occupies. Alright, but how much volume does this cube have? Well, since it was made by extending 1 square centimeter, a distance of 1 centimeter in the third dimension, we say that its volume is exactly 1 cubic centimeter, which is a common unit for measuring volume. So square units are used to measure area, and cubic units are used to measure volume. Since square units are made by multiplying two one-dimensional units together, like centimeter times centimeter, we can abbreviate them using the exponent notation, centimeters to the second power, or centimeters squared. And since cubic units are made by multiplying three one-dimensional units together, like centimeter times centimeter times centimeter, we can abbreviate them using exponent notation, centimeters to the third power, or centimeters cubed. And just like there were different sizes of square units, like square inches, square meters, or square miles, there's also different sized cubic units, like cubic inches, cubic meters, or cubic miles. See how area and square units are related to volume and cubic units? And there's another similarity too. Do you remember how you can use square units to measure the area of any 2D shape, not just squares? Well, you can use cubic units to measure the volume of any 3D shape, not just cubes. To see how that works, take a look at this 2D circle and this 3D object called a sphere, which is like a ball. Just like you can use a bunch of small squares to approximate the area of the circle, you can use a bunch of small cubes to approximate the volume of the sphere. And here's the really cool part. The smaller the squares you use, the closer their combined area will match the area of the circle. And the smaller the cubes you use, the closer their combined volume will match the volume of the sphere. Okay, so volume is a 3D quantity for measuring 3D objects. But since we've also talked a lot about area in this video, I want to point out that 3D objects also have a type of area that you don't want to confuse with volume. You might remember from our previous videos that 2D shapes have both a 2D quantity called area and a 1D quantity called perimeter. Well, in a similar way, 3D objects have both a 3D quantity called volume and a 2D quantity called surface area. Surface area is a lot like it sounds. It's the area of the object's outer surface or shell. Perimeter and surface area are both outer boundaries of geometric shapes. Perimeter is the one-dimensional outer boundary of a two-dimensional shape, and surface area is the two-dimensional outer boundary of a three-dimensional shape. And to help you see the difference between surface area and volume, imagine that you have a perfectly thin box filled with ice. If you unfold the box, you can see the 2D area that surrounds the volume, while the volume itself is the amount of 3D space occupied by the ice inside the box. Alright, so now that you understand what volume is, and you won't confuse it with surface area, we're going to spend the rest of the video learning how to calculate the volumes of some basic geometric shapes. But before we do that, I want to quickly mention something important about terminology, or the words we use to describe things in math. Most of the time, people agree on what to call things in math, but not always. And that's especially true when it comes to the words that we use to describe the dimensions of geometric objects. Take the words length, width, and height, for example. If I have a rectangle, I can name its two dimensions, length and width, like we did in the area video. but I could also name them width and height if I wanted to. The actual names of the dimensions really aren't important, so different teachers might use different names. The important thing is to be flexible and realize that the math concepts are the same, even if different words are used to explain them. For example, the area of a rectangle is always found by multiplying its two side dimensions together, no matter what they're called. Okay, back to calculating volumes. A lot of 3D shapes can be formed by taking a 2D shape and then extending it along the third dimension. For example, if you start with a rectangle and then extend it along the third dimension, you get a 3D shape called a rectangular prism. If you start with a triangle and then extend it along the third dimension, you get a 3D shape called a triangular prism. And if you start with a circle and extend it along the third dimension, you get a 3D shape called a cylinder. From the others, you might have thought that it should be called a circular prism. But technically, prisms are shapes that are formed by extending a polygon. And since a circle is not a polygon, the resulting shape is not called a prism. Okay, so the good news is that there's a general formula for calculating the volume of these types of 3D shapes. All you have to do is find the area of the original 2D shape that got extended and then multiply that by the length or distance that it was extended. Usually, that original shape is called the base of the object. So, let's start with this rectangular prism and calculate its volume. The base is the original rectangle, and its dimensions are 4 centimeters by 3 centimeters. So to find the area of that base, we need to remember how to calculate the area of a rectangle. To do that, we just multiply the two side dimensions together. 4 centimeters times 3 centimeters gives us 12 centimeters squared as the area. Now, to find the volume, we just need to multiply that area by the length that the base was extended. Our diagram tells us that distance is 10 centimeters. So if we multiply 12 centimeters squared by 10 centimeters, we get 120 centimeters cubed. So this rectangular prism has a volume of 120 cubic centimeters. Okay, let's try to find the volume of the triangular prism now. Again, the first step is to calculate the area of the base of the prism, which is the triangle. The formula for finding the area of a triangle is 1/2 of the triangle's base times its height. Be careful not to confuse the base of the triangle with the base of the prism, which is the triangle itself. Our diagram tells us that the base of the triangle is 10 inches and its height is 8 inches. So 1/2 the base times the height would be 1/2 of 10 times 8. 10 times 8 is 80, and 1/2 of 80 is 40, so the area of the triangle is 40 inches squared. Now all we have to do to find the volume is to multiply that area by the length that it was extended. We're told that the length is 50 inches, so we multiply 40 inches squared by 50 inches and we get 2,000 inches cubed. That's the volume of this prism. All right, are you ready to try finding the volume of the cylinder now? The cylinder is made by extending a circle, so first we need to calculate the area of that circle. As we learned in a previous video, the area of a circle is found by multiplying pi times its radius squared. The radius of this circle is 2 meters. So if we square that, we get 4 meters squared. Then we multiply by pi, which is approximately 3.14, and we get 12.56 meters squared. Now that we know the area of the circle, to find the volume of the cylinder, we just multiply that area by the length that the circle was extended, which happens to be 10 meters. 10 meters times 12.56 meters squared gives us 125.6 meters cubed. So the volume of this cylinder is 125.6 cubic meters. So, do you see how to find the volume of 3D shapes like these? Shapes that are made by taking a 2D shape and then extending it along a third axis? You just find the area of that shape and then you multiply it by the length that it was extended, and that gives you the volume. And it works for any 2D shape. It works for trapezoids or pentagons or diamonds or stars or hearts. All right, man. Now that I know how to accurately calculate volumes, playtime is way more fun. Of course, not all 3D shapes are made by extending a 2D shape along a third dimension. Some are made by rotating a shape around an axis, like the sphere we saw earlier in the video, for instance. One way to form a sphere is to rotate a 2D circle around one of its diameter lines. And another common 3D shape that can be formed by rotating a 2D shape around an axis is a cone. A cone can be formed by rotating a right triangle around one of its two perpendicular edges. Since the formulas for finding the volumes of spheres and cones are more complicated to explain, we don't have time to learn how we arrive at them in this video. So for now, it's best if you just memorize the formulas so you can use them on tests if you need to. To find the volume of a sphere, you use the formula volume equals 4/3 times pi times radius cubed. And to find the volume of a cone, you use the formula volume equals 1/3 times height times pi times radius squared. Let's try one example of each before we wrap up. Here's a sphere with a radius of 2 centimeters. Fortunately, that's the only dimension we need to find its volume. Our formula says that the volume of a sphere is equal to 4/3 times pi times radius cubed. Cubing the radius means multiplying it by itself 3 times. So we take 2 centimeters times 2 centimeters times 2 centimeters, which equals 8 centimeters cubed. Next, we'll multiply that by our approximation for pi. 3.14 times 8 is 25.12. And last, we multiply that by 4/3, which is the same as multiplying by 4, then dividing by 3, which gives us a volume of 33.49 centimeters cubed. Now let's try a cone. To use our formula to find the volume of a cone, we need to know 2 things: the radius of the circle that forms the base of the cone, and the height of the cone, which is similar to the height of a triangle. It's the distance from the point at the tip of the cone straight down to the center of the circular base. The radius of the base of this cone is 3 feet, and its height is 9 feet. So first, let's plug that radius into our equation and square it. 3 feet times 3 feet is 9 feet squared. Next, we multiply that by pi, again using 3.14, and we get 28.26 feet squared. You may notice that that's just the area of the base circle. But now we need to multiply that base area by 1/3 times the height of the cone. 1/3 times 9 feet is 3 feet. And 3 feet times 28.26 square feet gives us 84.78 cubic feet, which is the volume of the cone. All right, so now you know a lot about volume. You know that it's a 3-dimensional quantity of geometric objects, and you know that we measure volume with cubic units. You also learned how to calculate the volume of some basic 3D shapes. Of course, there's a lot of other 3D shapes that we didn't have time to cover in this video, but now you know about some of the most common ones. The key is to put what you've learned into practice by trying some exercise problems on your own. As always, thanks for watching Mathantics, and I'll see you next time. Learn more at mathantics.com.
Welcome to today's podcast on volume. In today's session, we are going to learn how to use a formula to calculate the volume of any rectangular or square prism. Firstly, what is volume? Pause this podcast and discuss this with the person next to you. Volume is the amount of space an object takes up. So, how many 1 centimeter cubes will fit inside the object? In class, you may have been using the 1 centimeter cubes to work out the volume of rectangular prisms. Today, we are going to learn how to use a formula to work out the volume of any rectangular prism. Before we start, it's very important that we know what unit of measurement we use to measure volume. When measuring volume, we use cubic centimeters or cubic meters. So, how do we calculate volume? To calculate volume, we need to use a formula. The formula for calculating the volume of a prism is length times width times height. We can also write it V equals L times W times H. So let's have a go at using the formula. This rectangular prism has a length of 5 centimeters, a width of 2 centimeters, and a height of 3 centimeters. Now, remember our formula? Volume equals length times width times height. So our prism has a length of 5 centimeters, a width of 2 centimeters, and a height of 3 centimeters. So to work out our volume, we need to times 5 times 2 times 3. Let's have a go. The first thing we need to do is times the length, 5 centimeters, by the width, 2 centimeters. So we need to times 5 times 2. So 5 times 2 equals 10. So 10 is the length times the width. Our next step is to times 10 centimetres, which is our length, times our width, by 3 centimetres, which is our height. So 10 times 3 equals 30. So the volume of our prism is 30 centimetres cubed, because we times 5 centimetres our length, times 2 centimetres our width, times 3 centimetres our height, which gave us 30 centimetres cubed. Now that you know the formula, let's have a go at doing the next problem. A truck has a trailer that has a length of 7 metres, a width of 2 metres, and a height of 4 metres. What is the volume of the trailer? Make sure you remember the formula. Volume equals length times width times height. So the volume of our trailer is 7 times 2 times 4. Pause the podcast here. You may wish to do this problem individually, in pairs, or as a class. How did you go? The volume of the trailer is 56 metres cubed. We are now at the end of our podcast. Thank you for watching, and I hope you have enjoyed learning about volume today. Now you know how to use the formula length times width times height to calculate the volume of a rectangular prism or a cube. You can download this podcast from your school's network onto your computer, laptop or iPod so you can watch it whenever you need to.
Adult Numeracy Level 2 Volume. How to work out the volume of a cylinder. Working at Level 2, you will be expected to use formula to calculate the volume of three-dimensional shapes such as cuboids, cylinders, pyramids and other prisms. On a Level 2 test, you will be given the formula. Before attempting, you should be confident at volume level 1, circles including pi, long multiplication, and most importantly formula, including bid mass. A cylinder is a three-dimensional shape, so the volume will be calculated in cubic measurements. The formula for the volume of a cylinder is V equals pi times the radius squared times by the height, V representing volume, R representing radius, and H representing height. This is a fairly similar formula to the area of a circle. As you can see though, the formula for the volume of a cylinder includes height. If you look at a cylinder side on, its cross-section is a circle. If you multiply this cross-sectional area, the area of a circle, by the height, it will give the volume of the cylinder. To actually calculate the volume using the formula, you will need to substitute the missing values in the formula. We can start with pi, which for this example we will use rounded to 2 decimal places, 3.14. The new formula now reads V equals 3.14 times the radius squared times the height. We can next substitute the R for the radius. The formula now reads V equals 3.14 times by 8 squared times by the height. Be careful. In some diagrams the diameter is given, in which case you would need to half to find the radius. Finally, we can substitute the height. The formula now reads V equals 3.14 times by 8 squared times by 10. Also be careful, in some test questions the units may be different. in which case you would need to convert to the same units before substituting into the formula. Now we have all the values in the formula, we can work out the volume. Remember, where numbers are together, this means times. As with all formula, we need to follow BIDMAS to remind us the order of the operations. There are no brackets, division, addition, or subtraction, so we will only need to concern ourselves with indices and multiplication. 8 squared is 64, so we can amend this in the formula. Now we can multiply all the values together. Remember, multiplication is commutative, which means it doesn't matter which order you multiply, the answers will always be the same. 64 times 10 is 640. 3.14 times 640 is 2009.6. The answer will be in cubic units. Looking back at the original question, as all measurements were in centimetres, we know that the answer is in cubic centimetres. The answer is 2009.6 cubic centimetres.
Let's see if we can figure out the surface area of this cereal box. And there's a couple of ways to tackle it. The first way is, well, let's figure out the surface area of the sides that we can see, and then think about what the surface area of the sides that we can't see are and how they might relate, and then add them all together. So let's do that. So the front of the box is 20 centimeters tall and 10 centimeters wide. It's a rectangle, so to figure out its area, we can just multiply 20 centimeters times 10 centimeters, and that's going to give us 200 centimeters. 200 centimeters, or 200 square centimeters, I should say. 200 square centimeters, that's the area of the front. And let me write it over here as well, 200. Now, we also know there's another side that has the exact same area as the front of the box, and that's the back of the box. And so let's write another 200 square centimeters for the back of the box. Now let's figure out the area of the top of the box. The top of the box is, we see the box is 3 centimeters deep. So this right over here is 3 centimeters. It's 3 centimeters deep, and it's 10 centimeters wide. We see that the box is 10 centimeters wide. So the top of the box is going to be 3 centimeters times 10 centimeters, which is 30 square centimeters of area. So that's the top of the box, 30 square centimeters. Well, the bottom of the box is going to have the exact same area. We just can't see it right now. So that's going to be another 30. And then we have 2 more sides, because this box has 6 sides. We have this side panel that is 20 centimeters tall. We see that the height of the box is 20 centimeters, and 3 centimeters deep. So 3 times 20, 3 times, let me write that a little bit neater. 3 times 20, that's 20 centimeters right there. 3 centimeters times 20 centimeters is going to give us 60 square centimeters. 60 square centimeters. Now that's this side panel, but there's another side panel that has the exact same area that's on the other side of the box. So it's 60 centimeters squared, or squared centimeters for this side, and then another 60 for the corresponding side opposite to it that we can't see. And now we can just add up all of these together. And so we get 0, let's see, this is going to be, let's see, carry the 1 or regroup the 1, it's a 100, and then we have 500. So we get 580 square centimeters is the surface area of this box.
This video is going to cover how to find the surface area of a triangular prism. First, we need to identify what surfaces we need to find the area of. We have 3 rectangles connecting the bases together, starting with the bottom base, the one formed by the hypotenuse, and then the one on the left. In addition, we also have our bases, which are triangles. Let's look at the rectangles first. Starting with the bottom, we can see it's a rectangle formed by the base of the triangle and the length of the prism. The area of the bottom would be 5 inches multiplied by 8 inches, which would give us 40 inches squared. The left rectangle is formed by the same dimensions as the first. We have a 5-inch leg from the triangle and the 8-inch length from the prism, giving us once again 5 inches multiplied by the 8-inch length, which will give us 40 inches squared. The last rectangle is formed by the diagonal or the hypotenuse of the triangle and the length of the prism. So its dimensions are 6.4 inches multiplied by our 8-inch length of prism, which gives us 51.2 inches squared. Finally, we need to add the area of our bases. As a reminder, the area of a triangle is 1/2 its base times height. In our case, our base and height are 5 inches each. If we multiply those together, we get 5 times 5, which is 25, and we need to divide by 2. However, because we have two triangular bases, we need to multiply it by 2. So those two kind of cancel out. So the area of our bases are just 25 inches squared. Now that we've calculated the area of all the faces of our prism, we can now add them together. This bottom face, if you remember, is 40 inches squared, and so is the side as well. The diagonal, however, was 51.2 inches squared. And let's not forget our two triangular bases, when added together, give us 25 inches squared. And finally, when we add it all together, we get 84.2 inches squared as the total surface area of our triangular prism. To review, finding the surface area of a triangular prism is not so different from finding the surface area of a rectangular prism. I find it is best to have some sort of system when you try to find the surface area of objects. For example, I like marking out the sides I have just found. For triangular prisms, you will have 3 rectangles you need to find the surface area of. One formed by the base, one formed by a diagonal, and one formed by the other leg. You also have 2 bases, which are triangles. The formula for area of a triangle is 1/2 its base times its height. However, because you have 2 bases, 1 and 2, you can almost ignore dividing by 2 because you will multiply by 2 afterwards.
What I want to do in this video is get some practice finding surface areas of figures by opening them up into what's called nets. And one way to think about it is if you had a figure like this, and if it was made out of cardboard, and if you were to cut it right where I'm drawing this red, and also right over here, and right over there, and right over there, and also in the back where you can't see it just now, it would open up into something like this. So if you were to open it up, it would open up into something like this. And when you open it up, it's much easier to figure out the surface area. So the surface area of this figure, when we open it up, we can just figure out the surface area of each of these regions. So let's think about it. So what's first of all the surface area? What's the surface area of this right over here? Well, in the net, that corresponds to this area. It's a triangle. It has a base of 12 and a height of 8. So this area right over here is going to be 1/2 times the base, so times 12, times the height, times 8. So this is the same thing as 6 times 8, which is equal to 48 whatever units were square units. This is going to be units of area. So that's going to be 48 square units. And up here is the exact same thing. That's the exact same thing. You can't see it in this figure if it was transparent. If it was transparent, it would be this backside right over here. But that's also going to be 48 square units. Now we can think about the areas of, I guess you could consider them to be the side panels. So that's a side panel right over there. It's 14 high and 10 wide. This is the other side panel. It's also, this length right over here is the same as this length. So it's also 14 high and 10 wide. So this side panel is this one right over here. And then you have one on the other side. And so the area of each of these, 14 times 10, they are 140 square units. This one is also 140 square units. And then finally, we just have to figure out the area of, I guess you could say, the base of this figure. So this whole region right over here, which is this area, which is that area right over there. And that's going to be 12 by 14. So this area is 12 times 14, which is equal to, let's see, 12 times 12 is 144 plus another 24. So it's 168. So the total area is going to be, let's see, if you add this one and that one, you get 96 square units. The two magenta, I guess you could say, side panels, 140 plus 140, that's 280. And then you have this base that comes in at 168. Let me do that same color. 168. 168. Add them all together, and we get the surface area for the entire figure. And it was super valuable to open it up into this net because we could make sure we got all of the sides. We didn't have to kind of rotate it in our brains, although you could do that as well. So 6 plus 0 plus 8 is 14. Regroup the 110 to the tens place, so it's now 110. So 1 plus 9 is 10, plus 8 is 18, plus 6 is 24. And then you have, and then you have 2 plus 2 plus 1 is 5. So the surface area of this figure is 544 square units.
Hi guys, it's me, Teacher Gon. In today's video, we will talk about how to calculate for the surface area and volume of a rectangular prism. So without further ado, let's do this topic. So basically guys, this one is under our series about solid figures. At ito yung una kong video na gagawin when it comes to the surface area and volume of a solid figure. So una natin, tinatawag nating rectangular prism. So para ma-realize natin yung pinaka-example ng rectangular prism, kung meron kayo sa bahay nyo, you can have a box para ma-imagine nyo yung tsura natin ng rectangular prism. So ito, I have here an example of a box na under ng rectangular prism. So, ang target natin ngayon, later on explain ko sa inyo kung para saan yung surface area sa yung volume natin. So, ang target natin kasi ngayon is to calculate for the surface area and volume of this rectangular prism. But before that, kailangan muna natin malaman yung formula na ginagamit in calculating the surface area and the volume. For the surface area of this rectangular prism, meron tayong dalawang formula or isang formula. We can use this formula, 2 times L times W plus length times height plus WH. Wherein, yung L natin, or ito, pwede natin simplify ito as 2LW plus 2LH plus 2WH. Wherein, yung L natin is your length. Medyo familiar naman kayo dyan. Your W is the width. Tapos yung H natin, it stands for the height of the rectangular prism. And for the volume naman, for the volume or letter V, ang formula na ginagamit natin is simple lang naman. We have the length times width times the height. So again, yung L natin stands for the length. Yung W natin is for the width. And again, your H is for the height. Since we already know the different formula for the surface area and volume of a rectangular prism, so punta muna natin, ano ba yung pinaka-calculate ng surface area? So imagine, you have here your rectangular prism. At alam natin, meron siyang 6 faces. At bawat faces na to ay mga rectangles or pwede natin calculate yung area. So yung formula natin, 2LW plus 2LH plus 2WH is the same as calculating for the area of this face, this one, this one, this one, this one, and this one. At kapag inad natin sila, yun yung magiging surface area natin. Again, ang nangyayari lang para surface area is that ina-add natin lahat ng area ng kanyang faces. Okay? So, yung surface area tayo. And for the volume naman, yung pinakamadaling term na, or words na gagamitin ko is that kinakalculate ito yung total capacity ng isang rectangular prism. So, let's say for example, I will open this box or this rectangular prism. And yung kinakalculate natin sa volume ay yung capacity o yung kayang ilagay sa loob ng isang rectangular prism. Okay? Yun yung difference nila. Again, yung surface area natin ay yung sum ng lahat ng faces ng ating rectangular prism, while the volume, yung kinakalculate natin dito ay yung total capacity ng isang solid figure. So let's start solving for the surface area and volume of this given figure. In this figure, yung ating length, we can designate this one as your length. This is your L. Itong 2 centimeters natin, this is your W or width. Tapos yung 4 centimeters natin is your height. Okay? Ito yung height natin. Ngayon, hindi na siya ganun kahirap. Some of the teachers are allowing the students to use their calculator. Pero naman kung hindi sila allowed, madali naman siya i-calculate. So let's say for example, we will solve for the surface area. Your surface area is SA. And then, ito na lang gagamitin natin ha. So you have, ito na lang siguro. Ito. Pero bahala na kayo kung anong gusto nyo. Pero for the sake of this tutorial, I'll be using the first one. That is 2 times LW plus LH plus WH. So you have 2 times, it's a matter of substitution lang naman. Diba? Your L is equal to 10 centimeters. You have 10 centimeters times your W, which is, which is 2 centimeters, plus your length, kasi L na to, you have 10 centimeters again, times your height, which is 4 centimeters, plus, ito naman, WH tayo, your W is 2 centimeters, times your height, which is 4 centimeters. Okay, simplify lang natin yung sa loob ng ating bracket. So we have here 2 times, we know that 10 centimeters times 2 centimeters, that will give you the product of 20 centimeters squared. Squared po yan Plus 10 centimeters times 4 centimeters, that is 40 centimeters squared. Plus 2 times 4, that will give you 8 centimeter squared. And then, add natin lahat sila. This is 2 times 20 plus 40, that is 60 plus 8, that will give you 68 centimeters squared. And to finalize your answer for the surface area of this given rectangular prism, simply multiply 2 by 68, and that will give you the surface area of 136 centimeter squared. This is the correct answer for item number 1. So, anong ibig sabihin nito? Ang ibig sabihin nito is that the sum of the area of all the faces of this prism is equivalent to 136 centimeter squared. That's it for the surface area. So, let's move on with the volume. For the volume naman, mas maiksi yung solution natin dito. We have volume is equal to length times width times height, wherein your length is equal to 10. So we have here V is equal to length times width times height. V is equal to 10 centimeters times your width, which is 2 centimeters. And then for the height, that is 4 centimeters. So your volume is equal to 10 times 2, that is 20, and then times 4, that will give you 80. Pero, eto na, marami kasi nagkakamali dito when it comes to unit of measurement sa final answer. Kapag volume kasi, 3D yan, guys, 3D. Ang mangyayari dyan, yung power ng ating unit of measurement ay cubic na. So we have here centimeter times centimeter times centimeter, that will give you cubic centimeter or centimeter cube. Okay? Makita niyo yung difference kapag surface area, since sum siya ng two-dimensional faces ng rectangular prism, square lang yung kanyang exponent. And then for the volume naman, cubic naman tayo. So in the next part of our video, I'll be giving you another example para mas ma-master nyo yung way on how to calculate the surface area and volume of a rectangular prism. Now, for example number 2 naman, we have here the problem. Find the volume and surface area of a rectangular prism with the sides 25 feet, 10 feet, and 14 feet. So, isipin natin ngayon, sir, wala tayong given figure. So, mahihirapan po tayo mag-solve niyan or mag-calculate niyan. Hindi siya ganun kahirap kasi you can assign either of, kahit alin sa kanila as your length, width, and height kasi hindi maging affected yung ating calculation as long as tama yung pagkakasubstitute mo. So let's say for example, your length is equal to 25 feet. Okay? Tapos, your width is equal to 10 feet. Pwede yan. And then, your height is equal to 14 feet. Okay? Para pare-parehas tayo. Now, remembering the formula of your surface area, unahin natin surface area. Surface area is equal to 2 times length times width plus length times height plus your width times your height. So, since designated natin L natin as your 25 feet, that is 2, and then bracket tayo, we have 25 feet times your width, which is 10 feet.
Nawalay lang talaga ako. Nalito ako.
Plus your length, which is 25 feet,
Hindi ko naalala, sir, na nasa drawing.
times 14 feet, plus your width, which is 10 feet, times your height, which is 14 feet. Okay, calculate natin sila. Medyo kulang tayo sa space. Okay, so that is 2 times 25 times 10. That will give you 250 feet squared plus 25 times 14. Sige, medyo malaki na yung number natin. Sige, try natin dito na 25 times 14. That is 0, 2, 4, 8, 10, 5, 1. That is, tama ba ako?
Grabe, nalito-lito ako kanina.
You have 4 times 5, that is 20. Carry 2. 4 times 2, that is 8 plus 2, that is 10. 1 times 5, that is 5. 1 times 2, that will give you 2. And 0, 5, 350. So 350 tayo. Okay? So this is 350 feet.
Wala siya sa lista.
350 feet squared plus 10 times 14 feet, that is 140 feet squared, is equal to, ito add natin sila, 250 plus 350, that is 600.
Sure.
Plus 140, that is 740 feet squared. 2 times 740 feet squared. Check natin 250 plus 350, 5, 6. Okay. Then multiplied by 2, that will give you the surface area of 1,480 feet squared. This is the answer for the surface area. Okay? So let's go with the volume naman. Volume medyo, kulang tayo sa space. It's equal to length times width times height. So that will give us 25 feet times 10 feet times 14 feet. Okay? So gagamit tayong calculator para mas mabilis yung ating video. Okay? This is 25 times 10 times 14. So again, 25 times 10 times 14. That will give us the volume of 3,500 feet cubed. This is the correct answer for item number 2 when it comes to volume. Yan. I hope na nakuha niyo yung way natin on how to calculate for the surface area and volume of a given rectangular prism. Though napakadali na nilang calculate, it's important for us to master the ways on how to do the thing of volume and surface area. So if you're new to my channel, don't forget to like and subscribe at i-hit na rin yung bell button for you to be updated sa ating latest uploads. Again, I am Teacher Gon. Maraming salamat and bye!
In this video, I want to talk about some 3D figures that you need to be familiar with, and we're going to go over some equations so you know how to calculate the volume and the surface area of these figures. And we're going to talk about how to distinguish or how to calculate the number of faces, edges, and vertices in some 3D shapes that we're going to consider today, and also in how it relates to Euler's formula. So let's go ahead and begin. The first shape that you need to be familiar with is the sphere. It's a three-dimensional object. The circle is two-dimensional. And so here's how we can draw the sphere. It looks like a circle, but I'm going to draw these lines to indicate that this is a sphere. Now you need to know that the volume of a sphere is 4/3 pi r cubed, and the surface area is 4 pi r squared, where r is the radius of the sphere. So make sure you write these things down because you need to know them if you have a test on it. Now the next figure we need to talk about is the cylinder. And it looks like this. This is just a rough sketch. So this is the radius of the cylinder, and here we have the height of the cylinder. The volume of a cylinder, it's the area of the base, where the base is basically a circle. The area of a circle is pi r squared. It's the area of the base times the height. So the base is pi r squared, and the height is just h. So that's how you can calculate the volume of a cylinder. To calculate the total surface area of a cylinder, it's the area of the base plus the lateral surface area. Now the area of the base is pi r squared, but notice that we have two bases, one on top and the one on the bottom. So it's 2 pi r squared. The lateral area is the product of the circumference of the circle times the height. So this is the distance around the circle is the circumference. And the circumference of a circle is 2 pi r. So you could use this equation to calculate the total surface area of a cylinder. Now the next figure that we need to discuss is the cone. So a cone has a circular base, and this is the radius of the cone, and here this is the height of the cone. So notice that we have a right triangle. So this is r, and this is h. Now the hypotenuse of this right triangle is known as the slant height, which is L. The volume of a cone is 1/3 of the volume of a cylinder. So it's 1/3 pi r squared times the height. Now the surface area is the area of the base plus the lateral area. Just like before, we know the area of the base is the area of the circle. And there's only one circle this time, not two like in the last problem. So it's 1 pi r squared as opposed to 2 pi r squared. Now the lateral area is the area around the cone. And it's 1/2 the perimeter times the slant height. The perimeter of a circle is 2 pi r. Keep in mind the perimeter is basically the circumference of a circle. And the slant height, that's just L. So we can cancel 1/2 and 2. Half of 2 is 1. So the surface area of a cone works out to be this equation. It's pi r squared times pi r L. Now how can we calculate the slant height? The slant height L, you could find it based on the right triangle. You can use the Pythagorean theorem to get it. So for a right triangle, c squared is equal to a squared plus b squared. And c is the hypotenuse, which correlates to the slant height. So L squared is equal to r squared plus h squared. So you can use this to calculate the slant height, and once you have that, you can calculate the surface area of the cone. And then you can easily calculate the volume of a cone using that formula. Now let's move on to the next shape. And this is the rectangular prism. So let's draw this first. So let's call this the length, the width, and the height. The volume of a rectangular prism is simply the product of those three values. It's the length times the width times the height. Now what about the surface area? How can we calculate that? Well, first, we need to add up the area of all 6 faces. So let's start with the face in the front and the one in the back. Notice that the area of each of those faces is the width times the height, where the height is h. And there's 2 of them, so it's going to be 2WH. So that's the area of the front and the back. Now let's calculate the area of the sides. So let's say the front side and the back side, or the side on the left. So notice that it has the length L and the height h. So the area of those 2 sides is going to be LH but times 2, or 2LH. And then we need to calculate the area of the top face and the bottom face. So it's the width times the length, and then times 2. So that's going to be 2LW. So this will give you the surface area of a rectangular prism. Now sometimes you may need to calculate the length of the diagonal. Let's call it D. If you ever need to do that, here's the formula you need. D is equal to the square root of L squared plus W squared plus H squared. And so that's how you can calculate the length of the diagonal of a rectangular prism. Now the next shape we need to talk about is the triangular prism. Now there's multiple ways in which we can draw this figure. So one way we can draw it is like this. The base could be a right triangle. It can be an equilateral triangle. So it could be many things. So in this example, let's say that this is the base, this is the height, and this is the height of the prism itself, which I'm going to distinguish it from this H by using capital H. Now we can also draw a triangular prism, like this. So this would still be H. In this case, this is the base, and this would be the height of the triangle. Now the volume of a triangular prism is the base times the height. Capital B is the area of the base, and the area of the base can vary. In this case, it's simply the area of a triangle. For a right triangle, you can calculate the area using this formula. It's 1/2 base times height. So this would equal capital B. Now let's say if you have an equilateral triangle where all 3 sides are the same. The area is the square root of 3/4 times s squared. Now let's say if you had a triangle where you have 2 sides and the included angle, the area is 1/2 AB sine of angle C. Now if you have a triangle like this, let's say if you know the base and the height, you could simply use A is equal to 1/2 BH. Now sometimes you may have a triangle where you're given all three sides, and let's say all three sides are different. If you need to calculate the area of this triangle, you need to calculate S first, which is 1/2 of the perimeter of the triangle. And then you can use Heron's formula to calculate the area. It's S times S minus A times S minus B times S minus C, and that result is all within the square root. So that's another way in which you can calculate the area of the triangle. So once you find the area, you can replace B with it, and then you can calculate the volume of a triangular prism. Now sometimes you might see a triangular prism drawn this way. And so you're still dealing with the same type of shape. This is the height of the prism. This is the base of the triangle, and you could say this is the height of the triangle. Now let's go back to this figure. How can we calculate the surface area of a triangular prism? Now keep in mind the formula can vary. This is the base, this is the height, and this is the height of the prism. The general formula is this: the surface area is the area of the base plus the lateral area. Now the area of the base is going to change depending on what type of triangle you have. Is it a right triangle? Do you have all three sides? Are the three sides different, the same? And so this can vary. But for this particular triangle, I'm just going to give an example. The area of the base is going to be the area of the triangle, which is 1/2 base times height. Now there's two of them. We have the triangle on the left and on the right. So we got to multiply that by 2. So for this particular example, capital B is 2 times 1/2 BH. Now the lateral area is going to be the area of the other three sides, or three faces rather. Let's call the third side of the triangle L. So since we have a right triangle, L squared is equal to B squared plus H squared. So if we wish to calculate the area of this face right here, the top face, it's going to be L times the height of the prism. So that's LH. Now let's say if we want to calculate the area of the face in the back, which is this face right here. It has a height H and another side length, which is lowercase h. So it's going to be H times H. And then if we want to calculate the area of the bottom face, it still has a height H, but a width of lowercase b. So it's going to be BH. So notice that it's basically the perimeter of the triangle, which is the sum of those three sides, H, L, and B, times the height of the prism. If you factor out capital H, you could see that P is equal to L plus H plus B. So for this particular example, the lateral area is capital H times L plus H plus B, and I'm running out of space. So thus we have the surface area is B times H plus L plus H plus B times the height of the prism. So make sure you know this. The lateral area is going to be the perimeter times the height. And so this is the surface area for this particular type of triangular prism. And you could use the general equation for all types of triangular prisms. Now there's one more shape that I want to cover, and it's the square pyramid. So it's a pyramid with the base of a square. So I'm going to draw it like this. So let's call this B, and this is going to be B as well. That's the length of the base. And here we have the height of the pyramid, which I'm going to call H. And this part here, that's half of B. If this whole thing is B, and this is the center, then this part here is, that's going to be B over 2. And then this part is the slant height, which we can call L. And this is the right triangle. Now the volume of a square-based pyramid is going to be 1/3 times the area of the base times the height of the pyramid. Now the base is a square, and the area of a square is length times width, or B times B, which is B squared. So capital B is equal to lowercase b squared. That's the area of the base, or the area of the square. So times the height. So therefore the volume of the square-based pyramid is 1/3 b squared times h, where lowercase b is the length of the square on the bottom. Now what about the surface area of a square-based pyramid? Well, we can use the general form for the surface area of any 3D shape. It's the area of the base plus the lateral area. Now we know the area of the base is b squared, but what's the lateral area? Well, notice that there's 4 faces of 4 triangular faces with 1 square face on the bottom. So I'm going to draw one of those 4 triangular faces. The height of that triangular face is the slant height, which is L. And it has a base, B. Now we know that the area of a triangle is 1/2 base times height. The base B is the same, but the height is no longer H, it's the slant height L. Now notice that we have 4 of those triangular faces. So this is one of them. Here's the second one. That's the one in the front. Then we have the one on the left side. That's the third one. And then there's the one in the back, the fourth one. So the lateral area is going to be this times 4. So it's 4 times 1/2 BL. And 4 times 1/2, or 4 divided by 2, is 2. So this is the surface area of a square-based pyramid. It's b squared plus 2bl, where L is the slant height. Now how can we calculate the slant height? Let's focus on this right triangle. And so c squared is equal to a squared plus b squared, according to the Pythagorean theorem. But c is the slant height, a, which we'll call b over 2, let's square that, and then b will be h. So if you need to find the volume, you could use that equation. If you need to calculate the surface area, first you need to calculate the slant height using the height of the pyramid and the base of the pyramid. Once you have the slant height, you could plug it into this equation to calculate the surface area. So if you want to combine these two equations into one, first we need to solve for L, taking the square root of both sides. So then you'll get this equation. L is the square root of, this becomes b squared over 4 once you square it, plus h squared. So I'm going to replace L with this equation. And first let's make some space. So you could say the surface area is b squared plus 2b times the square root of b squared over 4 plus h squared. So this will give you the surface area simply using the base and the height of the square pyramid. So here we have a rough sketch of a cube. And what do you think the volume and the surface area of a cube is going to be? Well, let's say the side length is x. Just like a rectangular prism, the volume is going to be length times width times height. So it's x times x times x. So the volume of a cube, it's x cubed, where x is the side length. Now what about the surface area of a cube? Well, for a rectangular prism, we saw it was 2L plus 2W plus 2LH. In this case, it's going to be 2x squared, or like 2 times x, but 3 times. So the surface area of a cube is 6x squared. So make sure you know these formulas. Now let's talk about the faces, the edges, and the vertices of a cube. This picture was a lot better than the last one. Let's call this A, B, C, and D. And this is going to be E, F, G, and H. So what are some of the faces of the cube? How many faces does it have? So notice that we have the face in the front. This is face A, B, C, D. Another one is the one on the side, D, C, G, H. That's this one. So a face is basically a flat surface. It's two-dimensional. Now how many faces do we have in this cube? So we saw that A, B, C, D was one face. That was the one in the front. We also have E, F, G, H in the back. That's 2. On the right we have C, D, H, G. That's 3. On the left, A, B, F, E. That's 4. The bottom, A, D, H, E. That's 5. And the one on the top, B, C, G, F. That's 6. So let's say that F is equal to 6. Now what about the number of edges? So what are some edges in this cube? Segment AB is an edge, so we can represent it like this. BC is also an edge. And CD, that's an edge as well. So let's calculate the total number of edges. So AB is 1, BC is 2, CD is 3, AD is 4, and then we have AE, which is 5, EH is 6, DH is 7, GH is 8, CG is 9, FG is 10, BF is 11, and in the back we have EF, which is 12. So a cube has 12 edges. Now what about the vertices? How many vertices does it have? So in a cube, you can identify a vertex where 3 edges meet. So A is a vertex. So it's one of the vertices. So this is 1. B is another one. That's 2, 3, 4, 5, 6, 7, 8. So there's 8 vertices in a cube. Now, Euler's formula tells us that the sum of the faces and the vertices minus the number of edges is equal to 2. So in this case, we have 6 faces, 8 vertices, and 12 edges. 6 plus 8 is 14. 14 minus 12 does equal 2. And so this is in harmony with Euler's formula for figures like these that are just made up of faces. Now let's apply it for a triangular prism. So let's call this A, B, C, D, E, and F. So what are some faces in this problem. So notice that ABC is one face of the triangle. Another face that we have is DEF. And also, we could say BEFC is a face of this triangular prism. Now let's calculate the total number of faces. So the first one, as you said, was ABC. The second one, DEF. The third, BEFC. Now a fourth one is the one on the bottom, ADFC. And then the one on the back left, ABED. So that's the fifth one. There's a total of 5 faces in this figure. Now what about edges? Let's name some edges. So AB is an edge. We could say that BE is an edge and DF is an edge. So we can write them this way. Now let's calculate the total number of edges. So this is 1, 2, let me write them. So this is AB is 1, BC is 2, AC is 3. DE is 4, EF is 5, DF is 6. BE is 7, AD is 8, CF is 9. So I calculated a total of 9 edges. Now the vertices, we just got to count the letters because that's where 3 edges will meet. So this is 1, 2, 3, 4, 5, 6. So I counted 6 vertices. Now let's use Euler's formula to confirm that this is equal to 2. So the faces plus the vertices minus the edge lengths has to equal 2. So we have 5 faces, 6 vertices, and 9 edges. 5 plus 6 is 11. 11 minus 9 is 2. So this is in harmony with Euler's formula. Now let's go over one more example. And so that is the square-based pyramid. So let's call this A, B, C, D, and E. So let's calculate the number of faces. So we have face ABCD. That's the base of the pyramid. Another face is AEB. That's 2. And then EBC is another one. So that's 3. And then ECD. That's 4. And then the one in the back, EAD. That's 5. So there are 5 faces in this figure. Now the number of vertices are the letters A, B, C, D, E. So there's 5 vertices. Now how many edges are there? So we have edge AB, that's 1. AE, that's another one. BE, that's number 3. Let's use a different color. BC is 4. EC is 5. DC is 6. AD is 7. And then ED is 8. So I got a total of 8 edges. So the faces and the vertices minus the edges has to equal 2. So F is 5, V is 5, and E is 8. 5 plus 5 is 10. 10 minus 8 is 2. So this is another figure that works in harmony with Euler's formula. And so that's it for this video. Hopefully it gave you a good introduction into 3D shapes such as spheres, cylinders, cones, rectangular prisms, square-based pyramids, and things like that. So thanks for watching.